Okay, so I'm recording now. Yesterday, or whenever the last time I saw you was, we did the first part of 6-3 and pages 1 and 2. And today we're doing the third page. What I want to do first is I want to do a quick review. So if you look at the front side of your notes, there are 6 different converse theorems that we learned. In 6-2, which is a section that was on our last quiz, all of our statements went, if a quad is a p-gram, then blah, blah, blah. Yesterday, I showed you that we're doing the converses of it. So I'm doing if blah, 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 then a quad is a p-gram. We learned 6 yesterday. I need 6 people to tell me each one thing that we learned yesterday. You can give me one of the statements. Okay, it is on the front side of your notes. Oh, give me one. Good. Both pairs of opposite angles are congruent, then it's a parallelogram. Eli, give me one. Good. One angle that's consecutive or supplementary to both consecutives, then it's a p-gram. Very good. We did both our angles. Isaac, give me another one. Good. If diagonals bisect each other, then quad is a p-gram. That's 3. We need 3 more. Megan? Good. 2 pairs of opposite sides are congruent. Then we have a p-gram. Missing 2 of them. Again, this is your notes from yesterday, not the homework I just passed out. This is the notes from yesterday. Can anyone give me one of the last 2? I've already talked to 4 of you. 2 more people. I need the last 2 statements. We did opposite angles were congruent. We did 2 pairs of parallel sides. We did 1 angle consecutive, or sorry, supplementary to its consecutive. We did opposite angles were congruent. What are the last 2? No, sorry, we didn't do, I guess we didn't do that one. We didn't do opposite angles were congruent. Isaac, you told me diagonals bisect each other, right? That's the one I forgot. Now I'm missing 1. So I gave you the 2 pairs of opposite angles are congruent. Griffin, do you know the last one? Very good. So Griffin gave us the last one, which was new yesterday. If I have 1 pair of opposite sides that's both congruent and parallel, then it's a p-gram. So I just reviewed all of the things that we learned yesterday. And again, if you were curious, they're in the front side of your notes right here. We just literally read all 6 of the things I taught you yesterday. Again, if you need a refresher, go watch the YouTube. The next thing we did is we made, look at a little chart, and we kind of teed ourselves up for today. We set ourselves all up ready because today we're going to do all of this math. So yesterday I kind of told you the 4 different methods that we could use to prove that a shape is a parallelogram. And those include finding slopes and distances and midpoints. And so that's what we're going to do today. We're going to do one giant example with all 4 of these methods using these math formulas. We did a couple other examples, and again, look at that online if you need to. But we're going to get into this 3rd page. So does everyone have your notes from yesterday up? Yes. Everyone have a pen or a pencil or a stylus? Ready to go? Perfect. Okay, what I want to do first is at the top of this page, I want to write my 3 formulas. I need to know slope and distance and midpoint. Who can remind me what the slope formula is? That's slope-intercept form. Give me how to find like actual slope. I'm so proud of you, but I want to know like actual slope is m equals. Flip it. Y's over x, rise over run, y2 minus y1 over x2 minus x1. So that's a common thing. We all think of slope as y equals mx plus b, but I actually want to know like what is m. So I wanted to remind us that. You might be like, oh, duh, of course we know that. Next thing I want to remember is the distance formula. Does anyone remember the distance formula? I'm going to say d equals
y1 minus y2. The square root of y1 minus y2 plus x1.
And both of them are squared. I usually write x first. It doesn't matter to me. You just minus the x's squared plus minus the y squared. Someone in one of my other classes was asking me about Pythagorean theorem. I did not prove this out for you, but distance is derived from the Pythagorean theorem. So if that's something you're interested in doing, as long as you show me enough work and I can follow, then I'll let that happen. So this is my distance formula, x2 minus x1 squared times y2 minus y1 squared plus, why did I say times? Write what I wrote, don't write what I said. Is anyone else's brain falling apart right now? Just me? Okay, no, some of us else. Good thing in 23 minutes we can all take a nap because we'll be done with class. Okay, well, some of you don't get to, but last one I have to do is midpoint. Does anyone remember the midpoint formula? Good. Very good, Allie. So it's essentially the average of the X's and the average of the Y's. Think about this. You guys just took 2 quizzes, right? If you wanted to see what the average quiz score you had, you'd add both quizzes and you'd divide by how many there are, 2. That's exactly what we're going to do here for midpoint. I'll zoom back out if anyone needs distance again, but I'm going to write midpoint. And I'm going to call that x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. The biggest thing I want to bring to your attention is that it's a plus, not a minus. We minus on almost all the other formulas. So sometimes people want to just assume things are minuses. They are pluses. All right. The reason I wrote that at the top of my screen is because I wanted to remember this later on. I wanted easy access to come back and look at it. So now I can look at the top of this page and be like, oh, there's slope, there's distance, there's midpoint. All right, is everybody with me? I'm feeling ignored. With me? Okay. Any questions so far? Okay, we're going to solve 4 different ways to show that this is a parallelogram. Normally we'd solve one way and be done, but we're going to do all 4 ways. Michael, you good? Are you good? Yeah, you look so confused back there. This is the notes. I can only see like a third of your guys' face, but I saw enough emotion that Michael had no idea what was happening. If you go to the notes, it's the 3rd page of our notes. It does look just like your homework though, and I did that on purpose, and I'm going to talk more about that later. So I have one picture, A, B, C, D is a quadrilateral, and I want to prove that it is a parallelogram. So I'm going to do my 4 different methods. The first one, it tells me show opposite sides have the same slope. Remember that if they have the same slope, that means that they're parallel. So I'm essentially proving that they are parallel. That being said, I want to use my slope formula. I'm going to write my slope formula down here just so I don't forget. I do really believe in muscle memory, and I think the more I write it, the more I'm going to remember it. And if you remember on our chart yesterday, I'm going to come back to this, but I'm going to zoom over to what we did yesterday. I said to prove that both sides were parallel, I had to do slope 4 times. So we're going to have to do 4 slopes. Okay, let's think about which 2 we should do together. Which 2 lines should be parallel? Eli? BC and AD. There you go. I want these 2 lines to be parallel. So in order to make this easiest for myself, I'm going to do those 2 slopes first, see how they compare, and then I'm going to do the other 2 slopes. So the other 2 would be AB and CD. Let's help each other out by splitting up the work. So let's do this. Let's do, girls, why don't you find slope for AD, and boys, you find slope for BC, and then we'll compare. This is just a quick like turn and talk, not a huge group project. When we're done, when you're done with that, we're going to do the next set. Gentlemen, you're getting a little loud. When we're done, we're going to do the next set, which will be A, B, and C, D. Again, boys, you pick one of them. Girls, you pick the other one. There's no need for us to do 4 slopes. I know you guys know how to do slope. That's not the point of this lesson, but we want to see how they compare. If you have 0 idea what's happening, I want you to watch me because I'm going to do the slopes. AD, I'm going to do -1 minus 3, 7 minus 1, -4 over 6. Make sure to simplify and make sure to always leave it as a fraction. Slope is not a decimal. I got AD and I got BC and I got -2/3 for both of those. Is that what everybody got? Good. Give yourself a high five. Next one. Now try AB or CD. If you have time, do both of them. See if they're the same. My biggest hint here is be super careful about positives and negatives, minuses and pluses. Easy to make mistakes. Let's try and do our math notes. Colin. Don't try to be watching movies. Try to do your math notes.
Oh, that was TikTok.
Mm-hmm.
I already did my math.
I don't want to hear TikTok either. Okay, I got 1 and 1 for A, B, and C, D. Is that what you guys got?
Yeah.
All right. That being said, that shows me that AD and BC have the same slope, which makes them parallel. And AB and CD have the same slope, which means that they're parallel. So I'm just filling in some little blanks. It was written in words. I don't have words for all of them, but AB and CD have the same slope, and BC and AD are parallel. Because opposite sides are parallel, I have a parallelogram. ABCD is a parallelogram. That is one method. Now, I personally like that method because it's not that hard to get 4 lines that have the same slope. It's not hard to do slope. The next one is going to be a little bit more time consuming. So each one of us is only going to do one. So this next one is show that opposite sides have the same length. Which formula am I going to use for this? Distance. Distance usually causes concern. So we're always going to be careful with distance. I'm going to go down here and write it here. X2 minus x1 squared plus y2 minus y1 squared. And again, we're going to kind of be purposeful with this. I did AD and BC together because they should have been the same slope. They should also be the ones that are congruent. So let's do this by rows. So Jeanette, your row. So you, Megan, Allie, and Michael, you guys find the slope for AD. Oh, sorry, not the slope, the distance for AD. That should be the same as what Allie's row is going to do. So Allie, Chantel, Jane, Griffin, and Alberto, I want you guys to find the slope of BC. Distance, everything is distance. Now, the last two will be between you 5. So we'll do Isaac and Ben and Colin. You guys find the distance for AB. And then Ty and Eli, you guys try CD. And again, you guys should have the same thing. You guys have AB. Eli and Ty are going to do CD. And then your guys' answer should be the same. I'm going to do it up on the board. So again, if you're lost, watch me. But everyone do one distance. If you get done early, try a different distance. Everything going okay in the back? It's iffy. The math is iffy.
Yeah.
I'll zoom back out, but I got my AD and I'm working on my BC right now. check with the person in front or behind you, or check with the person next to you because you should be getting the same answers. You're supposed to do DC. But you can see BC. I'm about to do CD if you want to do it with me. So here's CD. I'm doing my x's minus each other. So I'm going to do 7 minus 9 squared plus -1 minus 1 squared. I'm doing 7 minus 9 is -2. -2. A big common mistake is that we do -2 squared and we get out -4. I want it to be positive. All of these numbers should always be positive. Anything negative squares to be a positive because it's being multiplied by itself. It gets rid of it. And I get √8. Do not forget how to simplify your radicals. So I just quickly simplified mine. For A, B, and C, D, I got both of them to be 2√2. They came from √8. Anyone need me to show you how to get from √8 to √2? So if I get √8, make a little factor tree. 8 breaks down to be 2 and 4, and 4 breaks down to be 2 and 2. If you have two things that are the same, that gets to come out. So I have these two right here. Those get to come out to be 1. Anything that doesn't have a friend, doesn't have a pair, has to stay inside the radical. That's why I get a √2 under the house. Similarly, for the next one, AD and BC, I got √52. And then I simplified that to be 2√13. Again, if you're thinking about 52 as a factor tree, that becomes 2 and 26. And then 26 becomes 2 and 13. And the 2's get to come out and the 13 stays inside. I know we've done that like a long time ago. We did simplify radicals at one point on an ISEP sheet, but I know that you've slept between now and then. Any questions on what we've done so far? If you had trouble doing the distance, if you messed up and then you messed up and you messed up and you messed up, make sure to ask me. If you messed up one time, it happens. There's a lot of mistakes and I don't love to do distance because there's so much room for error. But if you don't understand why you keep getting the wrong answer, make sure that you talk to me because I want to make sure to clear that all up. Okay, so let's fill in the little blanks. It says AB is congruent to CD and BC is congruent to AD. And that makes my sides congruent. So I got a parallelogram. Perfect. Now, method number 3, I'm about to do no work. Oh, yeah, Griffin? Sure. On number 3, I'm about to do no work, but it's because y'all listening? Okay. I don't have to do any work because I already did the slope and I already did the distance. So it's saying that I have to show that one pair of opposite sides is congruent and parallel. If I haven't already found out that they're congruent and parallel, I'm gonna have to show that. But I've already done that. I'm not gonna make you do slope again or make you do distance again because we're in a different box. So it's talking about A, B, and C, D. What was the slope for AB? Can anyone remember? What was the slope? 1, what about BC? Oh, -2/3 for AB. Oh, AB was 1? Okay. What about CD? What was that slope? CD? 1? They all sound the same, so sorry. I'm sure that, whoa, stop. I'm sure that they all sound the same, but I'm talking about A as in ant and B as in boy, and then C as in cat and D as in dog. No, so they have the same slope. So if I didn't already have that, I would have to prove that. Can you please do what I would like you to do? This is as good as we're about to get. Okay, that's good enough. So they have the same slope. Now distance. What was the distance for AB? 2√2. Very good. And then what about CD? Also 2√2. So again, if we did not already find those, we would have to find those. That is true. Again, I'm not making us redo those simple calculations, but I'm writing them down here to show that I know that A, B, and CD are both parallel and congruent. And that is enough information to prove that they're a parallelogram. I could have just picked one set of sides and done both slope and distance. Now I've got one more formula I've got to use. I've got to use the last one we haven't touched yet. To show the diagonals bisect each other, that means that they have the same midpoint. So I'm going to use my midpoint formula, and I got to find the midpoint of these diagonals. But wait, team timeout. What are the diagonals? What's the diagonal? Which 2 points am I using to do one diagonal? B and D and A and C. The reason I say that, you might be like, duh, Miss White, we know what that is. However, you'd be surprised how you can get all mixed up in your head and try and do A, B, and C, D or something like that. So remember to look at the picture, know what the diagonals are. It looks like we're going to get a nice, pretty number. So let's go see if we can justify that. Let's again share the work. Boys, you find the midpoint for AC, and girls, you do BD. And we'll join together and see if they're the same thing. Again, I'm going to write my midpoint formula down here because I believe in muscle memory. And so, boys, I said do AC. Oh, that can't be good. Oh, okay. Did you guys get 5-2 for the one that you did?
Yeah.
Perfect. I think that's the easiest one. So I know personally, I would prefer to do that method. But if I ask you on a quiz or test, you have to do whichever one I tell you. Okay. That's it for new material, but I want to bring your attention to your homework. So I want you to pull your homework out. If you're doing it online, it's on the line. If you did it on paper, it's with you on paper. The homework looks just like this sheet. It looks just like this sheet right here. The first problem literally says, it gives you a set of points and it says use the slope formula. That's the first method we just did. The second one says distance formula. That is exactly what we just did on method 2. The third one, you will have to show work. I know that we didn't show very much work on our example, but you do need to show work on the third one to do 2 distances and 2 slopes. And then the last one is midpoint. Now there's also like 3 random problems on the back. So please, please, please make sure that you do the back. I do not see you tomorrow because it's a day 2, correct?
Yeah.
Correct. And I will see you, I will not see you on Thursday because it's a day 4. So I do not see you until Friday. So you've got a lot of, oh, I know, how sad to not have math for 2 days in a row. I will not see you until Friday, so you need to make sure that this homework is due by Friday. Again, next week I only see you 1 day, so you got to make sure that you listen to me when we're in person, listen to me when we're online, and read your Schoology because we will have a quiz next week. I guarantee it. So whatever day I see you, that's when you're going to have a quiz. I feel crazy. I don't know which day that is, but it's going to happen. All right, onliners. You guys have this homework. Again, I do not see you until Friday, but if you need anything from me between now and then, make sure to ask. And if not, I'm just going to let everybody work on their homework and then the bell's going to ring. So you guys are free to go unless you need me. So have a good day.
Thank you.